let's get started. I'm excited about this one. And today I'm joined by Michael Mature, solutions architect and engineer at Containus, as well as Adrian Martinet. I believe I butchered that last name. He can correct me on it later. But he is a sales engineer here at Containus, and he's here just in case anybody has any sales-related questions, and he can answer those impromptu. Uh, and myself, I am a developer advocate at Containus. I've been working in some way, shape, or form with distributed systems, cloud-native technologies for almost 5 years now. I do have some side projects I work on, and if you go look at our Twitter, I'm sure you can go read and listen to some of those if you're so interested. But yeah, today we're going to talk a little bit about exposing and securing your microservices and APIs, and we are going to record this, and you're going to be sent the recording in the next day or two. We're also going to share the resources that were used in creating this presentation, and we'll send you a copy of the slide deck as well. At the end of this session, we're going to do a short Q&A. If we don't get to your question, we'll respond to you via email and personally answer your question. Also, feel free to ask questions as we're going through the webinar if something pops to the top of your mind, because Adrian may be able to respond to you before we even get to the Q&A, or Michael, just depending on what the question is. So we'll be monitoring that. All right, so let's jump in and cover the topics. So first, we're going to kind of go over, why do we need to manage access and identity, in particular at the proxy layer? What problems does that solve, and why are people starting to move in this direction? After that, we'll talk about what is required to make this a reality, in that we need to secure the communications, and what is the way to secure those communications. And for the last part of the presentation, we're going to walk through how OAuth and OpenID Connect works in general. And for the demonstration part, Michael will take over and show us how TLS and mutual TLS work within Traefik, as well as how OpenID Connect integrates with an identity provider like Okta to provide identity along with authentication solutions. And then to wrap up, we'll do a summary and a Q&A session where we'll try and answer your questions. And if we don't know the answer, or if we don't get to it, like I said, we'll follow up with you. So first up, we're going to talk about the aspect of why we need to manage our access and identity at the proxy layer. What problems are we solving by doing it this way? Now, before we can talk about securing of the communications, it's critical that we talk about why it's important to have secure communications, and that's where this section comes in. So Traefik is a reverse proxy load balancer. It usually sits at the front edge of your network, not at the hardware layer, but at the software layer. And it takes incoming requests from all types of clients and can route traffic to all types of services and servers. Clients could be a MySQL, it could be RabbitMQ, it could be a web browser, it could even be an SSH client. And the servers and the services that sit behind Traefik can equally be as diverse, ranging from legacy applications, managed services or servers, and microservices. Now, all of these systems are capable of communicating over secure protocols that encrypt the data they send and also receive, so that ensures that no one can intercept that data in transit and steal sensitive information. The advantage to using something like proxy is that in front of all your applications is a secure layer that is positioned to manage that access and that identity, since it's essentially acting as a gateway. It's it's just in the perfect position as a trusted provider of routing your traffic. Now, traditionally, in addition to securing communications, web application services have largely been responsible for handling the identity and authentication portion of communicating with the clients. But when you start doing things at scale, when you have hundreds or thousands of microservices and they range in framework and language, this starts to become a logistics issue because of all those different languages, all those different frameworks, and all the approaches to managing those concerns just becomes one additional thing or 100 additional things you have to worry about. So in this webinar, we're going to discuss how modern systems communicate securely and how they handle the access and identity management portion of web traffic. And finally, we'll talk about how Traefik Enterprise and modern SaaS providers such as Okta and Let's Encrypt can manage these responsibilities instead of you and your teams having to manage it within your applications. So where do SSL certificates come from? So when two servers really love each other, well, I'm kind of practicing this talk for when I have to explain this subject to my son. And yes, I am actually talking about SSL. So trusted authorities create private keys and issue public certificates, which are distributed with popular clients and operating systems. And those authorities then sign these third-party public key pairs with a private key, which can be validated with the publicly distributed certificate. Let's Encrypt has become really popular because it's free. It can be securely automated with Traefik Enterprise and is a reliable solution for client-based SSL authentication. Now, I also realize that some people have figured out how to make Let's Encrypt work for mutual SSL, but that's outside of the scope of what we're going to talk about today, because I haven't looked too deeply into that, but I hear it's a pretty neat little workaround. Now, for mutual SSL certificate or encryption, many organizations depend on an internal certificate authority, since it can get really expensive provisioning third-party certificates. Now, these internal certificates aren't meant for end users, but instead they ensure that internal systems can both validate that they are who they say they are bidirectionally. This is critical for systems which communicate private information and sensitive data. So before we can talk about managing those identities and getting users logged in, we have to discuss how clients and servers can ensure that they are communicating with a trusted party. And for mutual TLS, that bidirectionally, both parties are who they say they are. Now we'll talk about how that happens in a moment, but with basic SSL authentication, which is the one way a browser wants to communicate with a web server securely, is the server isn't necessarily concerned with the identity of the client. It just wants to ensure that it can create a secure channel with that client. And so the responsibility is then on the client to validate the server's authority by checking it against a publicly available trusted database of certificates. And again, this is usually distributed with the browser or with your operating system. Now, in corporate IT environments, these can also be distributed by CA issuers managed by the corporate IT team. Now, with mutual SSL authentication, the situation is a little bit different. Both the server and the client authenticates the identities before exchanging the encryption keys. They both must have certificate authorities for the public keys they're exchanging, and the handshake takes 4 additional steps over one-way SSL authentication. So let's talk about how that authentication works. So in this scenario, this is what would happen if you were to go to visit google.com or some other secure site. The first step, the client actually sends a client hello message, which proposes the SSL options it wants to communicate with. Then the server responds with the server hello message, selecting the most efficient and secure option sent by the client. And then the server sends its own certificate, and the server concludes that part of the negotiation with a server hello done message. The client then sends the session key information encrypted with the server's public key in the client key exchange message. This ensures that the server can communicate with the client securely with that uniquely generated key that only these two parties know. And then the client will send the change cipherspec command to negotiate options for all the future messages that are going to be sent from this point forward. And finally, to wrap up the negotiation, the server sends the change cipherspec message to activate the options which were negotiated for all the future messages that were going to be sent. And then the server sends the finish message to let the client check the newly activated options. Once this is completed, you have a secure communication channel between your client and your server. Now, with mutual SSL authentication, it's very much the same thing, but instead both the server and the client are exchanging certificates before they exchange the encryption keys that they're going to use to communicate with each other bidirectionally. So now that we understand a little bit more about how that secure exchange happens, we can actually exchange identity and authentication within that communication protocol, whether it be between a client and a server or server to server. So here we're going to talk a little bit about how OAuth works and how things were before. And so prior to OAuth, let's just suppose a website wanted to access sensitive data on another site, and this would require you to share your credentials with that site so it could log in and it would access your data. And let's take this example as illustrated by David Neal, who is a developer advocate for Okta. We have a shady budget planning website, and this website would ask for your bank login in order to gather your transactional data. So this poses a few problems that OAuth is really well suited to solve. And that is, your login cannot only be used to view historical transaction data like this shady budget planner website is asking you for, but it could theoretically be used to transfer funds, gain access to private information, open new accounts or credit cards. There's all kinds of bad things that somebody could do with your bank login, right? So in addition to giving some shady website access to your bank account, you're sharing those credentials with an untrusted website, and that data could be improperly transmitted over the internet. It could not be encrypted using that SSL process that we just talked about. And it probably is being stored in an unhashed database somewhere, like maybe even S3, and somebody goes and can download it off S3. There's just all sorts of bad scenarios with this type of scenario. Luckily, we have OAuth, and that OAuth is here to solve that problem. So as we've mentioned, OAuth solves those problems. So in order to explain how OAuth works, let's suppose a hypothetical website exists which emails really terrible puns every single day to you. And you're thinking, this site probably does actually exist. I haven't looked for it. It probably does. But for the purpose of this webinar, it's fictional. Now, since I really like awful puns, I'm certain that every single one of my friends loves them as well. And so I want to forward puns to them every single day on my contact list, but that sounds like a lot of work, right? So it turns out that this website will do it for me, but I don't necessarily want to share my email login to the site for obvious reasons. Now, they just need my contact list. So this is where OAuth comes in. And OAuth will allow the terrible pun of the day website to access my contacts list without sharing my login information. So let's walk through how this might work. Now, you, being the pun lover, wants to share puns with everyone you know. They're going to love this. Super excited about it. Now, the Terrible Pun website includes OAuth integration with multiple email providers. Since we use Fleamail, we're going to choose that provider. Now, if you're already logged into Fleamail, Fleamail itself is going to ask you if you'd like to give Terrible Puns access to your contacts. If you're not logged in, you'll be prompted to log into Fleamail, not Terrible Puns, before being asked a permission grant. Now, if you allow Terrible Puns access, it will have access to your contacts until you disable that integration within Fleamail, or if your account just ceases to exist altogether, like you delete your account or something. Now, before we're going to walk through how all of this works, I want to cover some terminology we'll be using as I explain this process. So first we have the resource owner, and that's you. As the resource owner, you own your identity, you own your data, and any actions that can be performed using your identity. You have control over who gets that access and what actions they can actually perform. Now the client, this is the application that's actually requesting the access to your data or to any actions it can take on behalf of you, the resource owner. We have an authorization server, and this is the application server that knows the identity of the resource owner and where the resource owner has an account. And then we have the resource server itself, which is the application server or API that has the resources the client wants to use on behalf of the resource owner, being you. We have a redirect URI, which is the URL the authorization server redirects the resource owner back to after granting or denying permissions to the client. This is also referred to as a callback URL and will typically include data to complete the authorization handshake if there is an actual grant. And we have a resource type or a response type, and that is the expected response as defined by the client. In most cases, this is going to be some sort of authorization code, which is required by the client to authenticate with the resource service on behalf of the resource owner. We have a scope, which are the permissions the client is requesting and expects to receive from the resource owner. This can be actions or access to specific data. We have a consent, which is the authorization server acknowledging the scopes the client has requested, and this will prompt the resource owner on behalf of the client for permission, and you can either allow or deny. We have the client ID, which is used by the authorization server when identifying the client, and then we have the client secret, which is a key that only the client and the authorization server know. This enables the secure exchange of information between the two. This is very similar to how an SSL, when it negotiates that encryption key during that initial handshake process. And then we have an authorization code, which is a temporary code that is generated by the client in exchange for an access token by the authorization server. And then finally, we have an access token, which is the resource that is generated by the authorization server, which is then used by the client to communicate with the resource server itself. Now, the token effectively gives the client all the permission it needs to request data or perform those scoped actions on behalf of the resource server. So I know that's a lot of stuff to take in, so let's kind of jump through what an OAuth flow looks like. You know, what happens when you're actually going through this process and logging into or giving a website or a web server access to your data or to your capabilities with the API. So in step one, you being the resource owner would like to allow the Terrible Pun of the Day website, the client, access to your contacts so that they can send terrible puns to every single one of your friends. So in two, the client will now redirect your browser to the authorization server and include with that the request, including the client ID, the redirect URI, and the response type, as well as the permissions or scopes that it is requesting. In step three, the authorization server is going to verify who you are, and if necessary, request that you sign in. This is usually This is usually a prompt saying, do you want to use this account? And if not, sign into the right one. And once your identity is verified, the authorization server is going to present you a consent form based on the scopes which were requested by the client. You can either allow or deny those permissions to the client at this point. Once you've granted consent, the authorization server is going to redirect you back to the client using the redirect URI along with an authorization code. The client is then going to contact the authorization server directly and securely, sending its client ID, the client secret, and the authorization code. The authorization server then verifies that data and responds with an access token if everything checks out. And now that the client has the access token, it can then send requests to the resource service and access your contacts list. So where and how does OIDC fit into all this? What is it? Well, to explain that, we need to talk about how OAuth 2.0 was only really designed for authorization and for the client itself to request specific scopes and permissions from the resource server. OpenID connector, OIDC, is a thin layer which actually sits atop OAuth 2.0, which is why I went through that entire process of explaining what and how OAuth 2.0 works. That adds additional information about the person who is logged in. Now, the distinguishing feature about this is that a third party can then be responsible for defining scopes or permissions a particular identity has. This functionality has traditionally been served by an identity provider such as LDAP, since it provides information about the resource owner back to the client. So this enables things like centralized login functionality for SSO or single sign-on, as well as managing centralized access control for a diverse set of applications, much like you'd find in an enterprise environment. So the OpenID Connect flow looks exactly the same as OAuth. The only difference is that in the initial request, a specific scope of OpenID is declared, and then on the final exchange, the client receives both an access token and an ID token. So the ID token itself is what's referred to as a JWT token or JSON Web Token, which is a signed JSON object. What that means is that the client can detect if it's been tampered with or modified, and it contains information that is defined by the provider. In this case, the authorization server is the provider. In addition, with OIDC, there's a standard way for the client to request additional information from the authorization server, such as their location or their email address using the access token. So the primary benefit to using OAuth is that it's been widely adopted by so many authentication providers, such as Google, LinkedIn, GitHub, Facebook, and many, many more. Combining that with enterprise identity management tooling, such as Okta, allows for single sign-on management and identity management for your applications running behind Traefik EE. So what this translates to is individual services no longer needing to implement OAuth or OIDC, but allowing Traefik and Okta to handle all that work. In this example, what ends up happening is Traefik in the middle grabs that information from Okta and forwards it to the application in the form of headers or metadata, essentially, so that the application with its trusted connection to Traefik can ingest that data and allow or disallow the user to access particular functions or even general access overall. So I'm going to hand it over now to Michael, who's going to demonstrate how easy it is to configure TLS certificates with Traefik EE, configure the Okta OIDC provider, authenticate via Okta OAuth and OIDC, and control access permissions securely via those identities. So with that, again, if you have any questions up until this point, feel free to throw them into the Q&A 'A window, and I'll leave it to Michael. Thank you all.
Thank you, Kevin. Hi, everyone. So I will share my screen. I think it's good now. So for this demo, like explained by Kevin, I will show you how to install the product in a Kubernetes environment, and I will show you how to play with the mutual TLS authentication, and after I will show you how to configure and to secure an application with OpenID Connect by using Okta. So first of all, I will install the product. To install the product, we have a command line, tctl, that will help you to install a Traefik Enterprise in your Kubernetes cluster or in your Swarm cluster very easily, because it will generate all the installation file for you. And this command line can also be used to manage the cluster day to day, to create some resource, to delete some resource, like the ACME certificates, some credential, and TLS certificate. So to do this installation, I will use a command. This command is this one, the tctl setup gen, that will generate all the YAML file that will be used for the Traefik installation. So, and as you can see at the end of my command, I pipe everything to my kubectl apply. And here we go, everything is going to be installed in my cluster. So I will check that everything is up and running. I will have to wait a bit. So as you can see, there is two types of things, the controllers and the proxy. The controller will be in charge to listen the Kubernetes API and to retrieve all the information about the running pods with their IP. And the proxy will only a reverse proxy that will manage the incoming connection and will take the HTTP, TCP, or UDP request, analyze the request, and forward the request to the correct microservice. Here, as you can see, everything is installed and running. Now, the things we have to do is to deploy some configuration to tell to the proxies to listen on port 80 and port 443. To do that, we will apply a file, a static configuration. This is this file. So as you can see, I am creating some entry points. The entry points are the object in Traefik Enterprise that will be used to define the address that will be used to accept some connection. On my side, I will have two entry points, the web on port 80 and the web secure on port 443. As you can see with these three lines, I am creating a global redirection to force all of communication to be secure with HTTPS. Okay. Here I am enabling the API. On this line, I enable the Kubernetes CRD provider. So that means that the controller will listen all the custom resource definition that will be created in the cluster. And with these two lines, I enable the metrics for Prometheus. So now I have to apply this file, and to apply this file, I will use the tctl command, and I can apply a configuration by referencing the file. Before I apply the file, I will show you that there is no configuration available in the cluster. Static config. So as you can see, there is no configuration on it. I will apply my file, and now here we go. The configuration has been deployed and the proxy are ready to receive some requests. First things we will try to do is to access to the dashboard. To access to the dashboard, we will create an ingress route. We will apply this YAML file to create an ingress route. So this ingress route is created in the namespace Traefik, will be attached to the entry point web secure to allow only the communication on port 443. Here we will create a router, and in this router we are creating a rule. And this rule will be an host rule. If the incoming request match dashboard.webinar.containers.tech, so we will display the dashboard by referencing this internal service. And with these two lines, I will ask to have a TLS certificate, and I will reference a cert resolver. The things I have forgot is to create my cert resolver. So first of all, I will create my cert resolver in my static configuration. Sorry. So I have created my display. I have just created my certificate resolver here, as you can see. So I am creating a certificate resolver that will tell to my Traefik cluster to generate a TLS certificate through Let's Encrypt with the TLS challenge. I will apply again this file to have this cert resolver created, and now I am able to deploy my ingress with kubectl apply file Traefik key ingress. So I will create my ingress. My ingress has been created, so now I should be able to access to dashboard.webinar. I will access. Okay. Dashboard.webinar.containers.tech. Here, as you can see, there is a redirection, and I am now connected in a secure way to my dashboard with a valid Let's Encrypt certificates valid until the 9th of December of this year. So this is the dashboard of Traefik Enterprise Edition. As you can see, there is only one dashboard to have a view of everything in your cluster. You have the information about the controllers and the number of proxies that are running, and you have information about the ingress that are present in your cluster. So as you can see here, I have this rule, and this rule is secure with TLS. So everything is okay, I can access to my dashboard. So I will continue now with the MTLS part. So to do the MTLS, I will first of all show you what I will create, and here we go. As you can see, I have three files. The first file is to create a namespace. The namespace will be app MTLS. I will create a deployment to have a running version of my application running in my namespace, and I am creating a service to be able to access to my application. To access to this application, I will first of all show you that we can easily access it with TLS and with a cert auto-sign certificate, and I will show you after that we can use the MTLS part. Okay, so I will apply this file, and we will see here the application, the ingress route arriving in the dashboard in live. So I am creating everything. Everything has been created. I will have to wait a few seconds, and here we go, everything is deployed. Now here, as you can see, I can access to my application with this rule, with this domain name. So I will show you here that the certificate is the Traefik default cert. The Traefik default cert is the certificate that is used if there is no certificate provided and to secure at minimum the application. Now we will just enable the MTLS on it, and I will first of all I will show you that we can access to it. If I do this type of request, my curl is not very happy because it cannot verify the local issuer. So if I put a -k for the insecure mode, I have access to my application. Now the things I want to do is to have the mutual TLS authentication between my client and my server. To do that in Traefik Enterprise, it is very simple. We will create a secret here. I will create just after, and we will put some options. These options are the client authentication needed to be able to access to the application. So first of all, I will create my secret with my certificate. So I already generate all of my certificates on my laptop, and I will use this command to create a secret. I reference the CA, the certificate authority chain, my server certificate, and my server. And I am creating the secret. Here we go. And now I have updated this file, so I have to reapply this file. I reapply everything, and as you can see, something has been configured here. Okay, so now if I execute my curl request, alert bad certificate. Curl is not able to connect to my application because I am not using the correct client certificate. So to use so I have some client certificate on my laptop. So I will now execute the command with my client key, my client cert, and my CA. And here we go. I can access to the application with MTLS. So my client has the certificate, and I can access to the application. I will continue with the support of OpenID Connect. So I will delete my previous installation. Sorry. I'm deleting everything. It's deleting the namespace. It's taking a few seconds. There we go. Now I will show you how to enable to use the OpenID Connect integration. Same things. I will create a namespace for the installation app. I will deploy a WAMI service, the same service as before, and I will create an ingress route. This ingress route is pretty the same. I will ask to have a TLS certificate generated through Let's Encrypt with this line. And for now, I will not enable the OpenID middleware, but I will create the middleware. I will apply this file. And everything has been created. Here, this is the middleware that will be used to be able to secure my application. So first of all, I will show you that I can access to the application without any securization. There we go. I can access to the application. So as you can see, if I refresh, I am load balancing between all the replica of the application. Okay, so now I will have to enable the OpenID on this on it. So the middleware is created, as you can see. Here I am referencing an auth source, OIDC source. This auth source needs to be created in the static configuration. So I have created here in the static configuration my auth source. Here, just here, as you can see. So here I am referencing the Okta URL for my issuer. I am referencing the client ID and the client secret. And this is the only things we have to declare here in the static configuration to be able to enable the integration with OpenID. After, we have to create some middlewares, and these middlewares will be attached to the ingress route to be able to secure the application. So I will apply this static configuration. And here I will just have to reference the middleware created before, OIDC host, this middleware, and I apply my YAML file on my Kubernetes cluster. And here, as you can see, now I have the middleware OpenID OIDC host that will secure my application. Now, if I go here and I refresh my page, oh, I have a bad request. Why I have a bad request? I know it's because I haven't the correct redirect URL. So I will go on my Okta application. Here, as you can see, I haven't the correct login redirect URL because I have changed my domain. Webinar and webinar. I will save that. Here we go. And I will try again. Here we go. So now I can connect to my Okta with my admin account, and I have access to the application. So as you can see, I have a bearer token right now, and my communication with the application is secure. Okay. So there is two other options that are very interesting in this middleware: the forward headers property and the claims property. I will start with the forward headers. So the idea of this forward headers property is to extract some data from the claims. In my case, it will be groups here, and I will extract the data available in the claims and put all of this data inside my new header, HTTP header, X traffic groups. So here, as you can see, this is the GWT token that is used. So if I inspect this token and I take the value, I will inspect this token. Here, I can put everything here. So I have some issue here. Okay, there we go. So as you can see, here, I have only one group, the manager group, because I am connected with Michael plus manager at container.us. I have only one group here. So if I enable these forward headers, I will have a new header with the value manager. So I update the file, I will apply the file. I apply the file. There we go. And here, if I refresh the page, as you can see, I have a new header manager. Pretty simple. One other property is the claims. The claims will be used to delegate some authentication to the reverse proxy. So that means that I will allow only users that have the group admin in the claims groups. So here I have updated the file. I will just apply this change, and now if I refresh, I should be forbidden to access to this resource. And as you can see, I'm forbidden to access because I haven't the admin group in my list. To test with people that have an admin group, I will log out. I open the new session. And in this new session, I will use Michael at container.us. I sign in. And here we go. I have access to the application. And as you can see, I will zoom a bit. Here, I have the X traffic groups value available, admin, user, and manager. So that means that you can extract some data and put it in a header, and also you can base the authorization based on the value available in the claims. So there are a lot of terms available, and you can create some rules here to allow access to the application. So that's pretty much it for me for the demo. Hope you enjoy it, and I will let you continue, Kevin. Thank you.
So just to wrap up real quick, we saw that Traefik EE allows for simple to use SSL certificate management with Let's Encrypt. We have out-of-the-box support for enterprise authentication providers through the OpenID Connect middleware. And Traefik EE can effectively be used as a secure gatekeeper for all of your managed services. Now, everyone who registered for this webinar is going to receive a recording in a few days, as I mentioned at the beginning. And included with that is a free trial of Traefik Enterprise Edition. If you have any questions, feel free to reach out to Adrian or anybody through the contact form on the website.